Okay, here we go. We're going to start learning about fatty acids. Fatty acids, as we have said, are what we can call the building blocks. These are the building blocks of energy lipids. They're also the building blocks of membrane lipids, but we're not paying attention that much to membrane lipids. We want to look at the lipids that our body can get energy from. Look at this table that you see in front of you. It shows about a dozen different fatty acids. These are the fatty acids that our body and nature uses to build the different lipids that it builds. So first thing to notice, there's more than one. This is not just a single fatty acid. There's about 12 fatty acids that our body uses. That's the first thing we want to notice. This is a category. Fatty acids are a category of molecule. What's the second thing we'd like to notice? Let's look. Look at the structure. Carboxylic acid, carboxylic acid, carboxylic acid, and so on. Every single fatty acid contains a carboxylic acid functional group. The carboxylic acid functional group is where the name acid in fatty acid comes from, because every fatty acid has a carboxylic acid functional group. What else does every fatty acid have? It has a hydrocarbon chain. You know what hydrocarbon means. It means just hydrogens and carbons. The hydrogen and carbon part of it is called the fatty part of that structure. It's a hydrocarbon chain, which is fat soluble. Fat soluble is where the word fatty comes from. So all of these fatty acids, all of them that you can see here, they all have a carboxylic acid and a long hydrocarbon chain. Long hydrocarbon chain. Long hydrocarbon chain. That's how you'll recognize if something is a fatty acid. Long hydrocarbon chain with carboxylic acid at the end. What do we mean by long? Well, let's look. If we count how many carbons here, let's say take this for example, I'll count the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 carboxylic acids, and that's typical. This one here, if you count, this has 20, this has 18, this has 16, this has 14. This one down here has 22. But notice it's, a number in that range, 12 to 22 about. That's about how many carbons are in a carboxylic acid. It's not a number as small as 4, and it's not a number as big as 40 or 50. It's in this range. Also, you'll notice that the number of carbons is always even. We'll talk more about that later, much later, but just notice it for now. It's always an even number. If you count and you discover that it's an odd number, something's wrong. Double check, it should be an even number. And notice we also count this carbon. That's a carbon, so it gets counted. You probably have noticed I started at this end to count. We're not doing IUPAC naming here. If we were, we would number from the end with this functional group. We're not doing IUPAC naming. In fact, you can see the names that are given here. Those are the common names. And that's usually, in fact, always how it's done in biochemistry. These are referred to by their common names. Lauric acid, myristic acid, and so on. So we're not numbering to name it. What else do we notice? Well, you see here that all of these, in the top group, all the carbon-carbon bonds are single bonds. There are no carbon-carbon double bonds. That's what the word saturated tells us. Saturated means there are no carbon-carbon double bonds. When we were talking just about hydrocarbons, we would have referred to these as alkanes, but usually in nutrition and medicine and biochemistry, these are called saturated. These are saturated, no carbon-carbon double bonds. All these fatty acids are unsaturated because there is a carbon-carbon double bond here, and here, and here, and here, and here. Depending how many there are, we say we either have a monounsaturated fatty acid. Monounsaturated means exactly one carbon-carbon double bond, Or we say we have a polyunsaturated fatty acid. Polyunsaturated means 2 or more carbon-carbon double bonds. We're not talking about this carbon double bond O that's in the carboxylic acid group. You know that that's the abbreviation for carboxylic acid. We're not talking about a carbon-oxygen double bond. Saturated, unsaturated refers to carbon-carbon double bonds. What else do we notice over here, these different types of notation? You see this, 12:0, 14:0, 16:0, 18:0, and so on. That's a notation. The structure notation tells us something about how many carbons and how many carbon-carbon double bonds. The first number is how many carbons there are. The second number is how many carbon-carbon double bonds there are. All of these, of course, have 0 for the second number because these are all saturated. 0 carbon-carbon double bonds. If the second number is 1, that means monounsaturated. If the second number is 2 or more, that's polyunsaturated. The final way that we'll classify fatty acids is something that you've probably seen in magazines or the newspaper or the news or at the grocery store, and that's this, omega, the omega notation. This is pronounced, I'm going to write how that's pronounced. This is written or pronounced omega-6. This is the lowercase omega, the Greek letter omega. Omega-6, omega-7, omega-3, that's a notation used in unsaturated fatty acids. And here's what it is. This tells you the carbon number of the very first double bond. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. That first double bond right there, I'll highlight it. This first double bond starts on carbon 6, so we classify linoleic acid as an omega-6 fatty acid. Linolenic acid has its first double bond start at carbon 3, and so it is an omega-3. Omega-3 because the double bonds, the first one, starts at carbon 3. You'll notice we did not number from the acid end. We numbered from the fat end. Omega-3 fatty acid, we number from the fat end. Finally, you see up here omega-7, omega-9. For these two, you've really, I'm sure, not ever heard of omega-7, omega-9. Those are not in the magazines or newspaper or news. Here's why. These fatty acids your body can make. These are called non-essential fatty acids. Your body can make those on its own. They don't need to be in your diet. The fatty acids that your body cannot make, that must be in your diet so that you can have them, are called essential fatty acids. These are essential fatty acids. Omega-3 and omega-6, these your body cannot make, and so they must be in your diet. So we can still classify this omega-7, omega-9, but if we wonder why we don't see omega-9 supplements at the grocery store, it's because your body can make that fatty acid. This notation here we won't be using, so you don't need to pay attention to this. In our next video, we're going to take a look at what kind of reactions these fatty acids can do. That's up next.